In this video, I will discuss how to form amides from acids using DCC. And my name is Abia Usman. So, when we first start thinking of converting an acid to an amide, we might think of using an amine group. The problem with this, though, is that carboxylic acids are strong organic acids, and NH3 and amines are bases. So they undergo an acid-base reaction to form an ammonium salt before any nucleophilic substitution occurs. This then yields this product, which can then be dehydrated to form an amide. However, the yield can be low. Therefore, I will discuss how to use DCC in this reaction to get a greater yield, since this is not very effective. So the way that a carboxylic acid and an amine group can readily react to form an amide is when it is in the presence of the additional reagent DCC, which is then converted to the byproduct dicyclohexylurea in the course of the reaction. By the end of this reaction, water is added on to DCC and is a leaving group. Now we'll look at the first part of this mechanism when DCC is used to form the amide. So this first part of the mechanism consists of two steps that convert the hydroxyl group into a better leaving group. And this process, this whole part one, activates this group towards nucleophilic attack in part two, which I will discuss in the next slide. So this group over here donates electrons to the carbon on the DCC, and this carbon then donates electrons to the nitrogen. So if we go to the next step, the nitrogen now has a negative charge on it, which can then grab the proton off of here and push the electron pair onto the oxygen, making both the oxygen and the nitrogen neutral. And so then after this proton transfer occurs, we have an activated carboxylic acid molecule. Now we'll look at part two of the mechanism using DCC. In this second part, basically deals with the addition of the nucleophile and the loss of the leaving group. So now in the first step, we can finally add our amine group, the ammonia, because the DCC has activated the carboxylic acid. So now it's a basic of who has electrons and who wants them. Ammonia has electrons, and the carbonyl carbon on the carboxylic acid wants them. So the electrons are transferred and it pushes them onto the oxygen. So now that we have a good leaving group here, the electrons on the oxygen can come down to reform the carbonyl, and then pushes off the oxygen to form the new carbonyl. However, that would make carbon have 5 bonds, so then the electron pair gets pushed on to the nitrogen. And now the final step of proton transfer occurs here. So we have our protonated amide here and a nitrogen with a negative charge. So this is going to grab the proton here and push it onto the nitrogen to form our amide, and it's also going to form a byproduct of dicyclohexylurea, which is very stable. And that's how we form the amide using DCC. So now we'll look at a sample problem. This is a synthesis problem, and I encourage you to pause the video and see if you can do it on your own, and then I will explain it. So basically, we first use hydroxide and water, which then forms our carboxylic acid, and to get it from a carboxylic acid to this amide group over here, we use what we've learned in this video, which is using DCC to do this in one step.